Okay, so now we start looking at the solutions to the questions that were in our Workpack 2 for this week 2. So this is Form 4 revision, and I'll go through all the questions with you. So on Monday, we needed to do these following questions, so we'll do Monday today. So calculate the area of this sector of a circle. So now to do that, we are going to do this. So since we know that the area of a sector is given by theta over 360 times pi r squared, okay, and we have this sector here given where our theta is 60 and our radius is 7.5. So now our duty is now to just substitute these terms in our formula, and then we see what we're going to get there. Okay, so what we are going to have now, let me just okay, okay, so in our revision workpack week 2. Okay, so welcome to today's video review lesson on revision workpack 2 for form 4. Okay, so let's just look through the questions. So for Monday, question number 1 was given a sector, calculate the area of this sector. And at this point, we should be familiar with formulas. Okay, this is the formula for finding the area of a sector, because since a sector is just a part of a circle given by a certain angle, there we are. So we know that the radius is 7.5 and our theta in this case is 60. So to find the solutions to this, we're going to say area is equal to, so now once we do that, theta is 60 over 360 times pi times 7.5 squared. Okay, so if we do that, if we punch that on our calculator, we know that 60 over 360 is 16 times 7.5 squared pi. So we need to simplify that on our calculator. So we know that 7.5 times 7.5. So we're going to have 52.5 over 6 pi in terms of pi. Since I'm not using a calculator to simplify, but you can then have your answer written as a decimal. You can simply just divide that by pi. So this would be our answer here in terms of pi, which if you want, you can do 52 divided by 6. So we do that. So this gives us 8.75 pi. So this is in terms of pi. If you have a calculator, you can work out what that pi is. So that's our answer in terms of pi for the area. The secret is to know the formula. So then we move on to number 2, which is a vector question. We've been given that the vector u is that, and then the scalar vector for that is that. So the scalar is that, and another scalar is that. And then they say we find u minus 2v. Now we know that when we're given in terms of scalar quantities, it's x on top and y down. So in this case now, our u is 3 and then negative 2. And we are subtracting this with 2 multiplying negative 12 and 5. Okay. So what we do here basically is that this 2 is a multiplier and it multiplies everything inside there. So we can come down in next step here, and then we know that this is going to be minus negative 24, since 2 times that is that, and then 2 times 5 is 10. And we know that x components add or subtract together, and then the y components add and subtract together. So what we have there is to know that 3 minus 24 should give us 27. At this level, we must know that that will turn to positive, and then negative 2 minus 10 should give us negative 12. So therefore, the solution to this question is simply going to be equal to 27 over negative 12 as that. And then they say we find the modulus of V. Now, modulus of V, in our notes, we said this is magnitude, and magnitude is simply given by square root of the x component squared plus the y component squared. So in this case, we are talking of the x component of V. So V, the x component of V, is negative 12 squared plus the y component, which is 5 squared. Now, negative 12 squared is 144. So we have a situation here where we're dealing square root of 144 plus 25. So we need to know what 144 plus 25 is, which gives us 169. So we've got square root of 12 times 12. We've got square root of 169, which should be a common square root there. So square root of 169 should be 13. So this gives us 13. So meaning the magnitude of V, or the length of V vector, is 13. So very important. What is important is to know that modulus means the length or the magnitude, and you remember this formula here. The rest is just substitution. Now we go to question number B, still on vectors and scalars. We are given point from A to B. So what is important here is to have a sketch. Let's say we've got A here, and then we are moving to somewhere B. Okay, so if we draw a connecting line there to move from A to B, we are told that it's 6, negative 1. Okay, so this is A to B. These are not drawn to scale, and they are not to mean anything. They are just for direction. And then B to C, we are told that from B to C, we have negative 2 and 5. Okay, the direction is that. And we are told that we've got a point D somewhere. So let's say the point D is somewhere here. I'm not saying the shape should have come out like this on the Cartesian plane. This is just for direction purposes. There is a point D where DC, moving from D to C, in that order we go to negative 3. Okay, now all points on vectors must connect. So let's say this is the shape that we have, but I guess on the Cartesian plane it can be a proper shape of 6 units down, then you start going, but this is just for me to be guided in terms of directions. Now they say find AC. Remember, to move from A to C like that, which is that, we need to go AB plus BC. So now AC means we are going to cover AB, this is why the diagram is important, plus BC. Okay, now if you look at this, these are already given. Our AB is 6, negative 1, plus our BC, which is negative 2 and 5. If we add these, we are finding that 6 plus negative 2 is 4. 1 plus 5 is 4 again. So this answer here should have been 4, 4. And then they want us to find BD, to move from B to D like that. You can either move BA and AD. Now, if you look at this, we do not have AD. So the easiest thing to move from B to D down here in that direction, we must move that BD should be equal to BC and CD. Now BC, the vector like that, plus CD. Now if you look at this, BC is given as -2 and 5 plus. Now if you look at CD is going against the direction of DC, which is given, so meaning CD is simply equal to the negative of, so let me just explain that better. CD is equivalent to negative of DC, okay, since we are going against the direction. And then here we already know that this is 2 and 5, and then minus 2, and so we are putting a minus there, -2, and that -3. The reason why we are putting a minus is we should have added, but we are going against the direction. So if you do your arithmetics properly here, this is going to give us -4, and then negative plus, then 5, 8. So we get this as -4, 8. What is important is that here we needed to move CD, but what we were given is DC. So meaning we are going against the direction of the given vector. So we will subtract instead of adding, or just swap the signs on the components. Now they want us to find, remember again, it has come back here. This means modulus, which means distance. So they want us to find the length of the vector BC. Now to find the length of the vector BC, it's the same formula. It's root of the x component squared plus the y component squared, which should mean the x component squared, the x component of BC is -2, so we put -2 in brackets, plus the y component, which is 5, which is 5 squared. This whole thing here should give us square root of 4 plus 25, and this is simply root of 29. So this is our answer for question number 3. Now let's see what else was the question for Monday. Again, we are still on scalars. So to do this, we are still on the same concepts, and they should be easy. So now here they are asking us 3a means we multiply a by 3. So we can actually start up top here. 3a means -3, 2. You multiply 3 with all these numbers there, which gives us -9 and 6. This is what 3a is equal to. And then 2b. 2b is simply 2 times 5 and 4. So this is 2b, which should give us 10 and 8. If we do that, then we just bring these. So we want to subtract this and that. So we've got -9, 6, minus 10 and 8. Now if we do this, you would find that we've got -19, and then 6 minus 8 should give us -2. So the answer here is -19 and then -2. Okay, so if we've done that proper, again, now modulus of a, modulus, these two lines mean magnitude. Again, same formula, which is important for people to know. X squared plus component y squared. Our x component on a is -3, so we'll put -3 squared in brackets, and then plus our y component, which is 2, which is that, and then here 3 squared is 9, 2 squared is 4, and these are under square root. So the answer is just root of 13. If you've got a calculator, if it's in paper 4, you can write this as a decimal. If it's in paper 2, this is correct, and it's a good answer. So you can see that vectors are very important. So that's for Monday. And I must say the other questions for Monday, okay, Monday had quite a bit. So then here we can move to question number 5. They are saying the region shown shaded in the diagram, they want us the region shown shaded in the diagram. So we've got this pipe, I don't know, it's the boundary of the path is formed, okay, by two semicircle, meaning center O, okay. The inner semicircle has radius, so there is a semicircle, so it's important to draw some form of imaginary radii here. So this is 7 from here to there, just as it is there. Then they tell us that this path is 2 meters, meaning from here to there is 2 meters, which means the bigger semicircle has 9 meters, okay. Then they say work out the perimeter. So now, since this is a semicircle, the perimeter first, we must find the length of the arcs, the smaller one and the bigger one. Then we add 2 meters, 2 meters. So here, to do this, you just need to remember the formulas for the arc length. So for the smaller one, this smaller arc here, we are going to say theta over 360 times 2 pi r. We already know these formulas and they are part of the formula sheet that is given. Now in this case, since this is a semicircle, the angle theta is 180. So you've got 180 over 360 times 2 times pi times 7. You know that 180 360 is half, so we have a situation of half times 14 pi. Why we're getting 14 pi? It's because 2 times 7 is 14, and the question says we must answer it in terms of what? Pi. So the arc length for the smaller one, which means this one here from here to there, is actually 7 pi, okay, if we do half of 14. Now we need to do the same for the bigger arc, the one moving around there, okay. The bigger arc, remember, from the radius to from the center to this first radius is 7, then there's an added 2 meters there. So we are going to do 180 over 360 times 2 times pi times 9. Again here we must remember that 180 over 360 is half, then 2 times 9 is 18 pi, then half of 18 is 9. So this implies that what we are going to have for the arc length of the bigger one is 9 pi, okay. So now we've got a situation where we've got the bigger arc, which is this one here, which is 9 pi. Then we've got the smaller arc here, which is 7 pi. Now these two from here to there, we are told this is 2 meters, and again here from here to there we've got 2 meters. So if you look at this now, to find the perimeter of this, it's the distance around the shape. So we're going to do 7 pi plus 9 pi. So 7 pi plus 9 pi, then plus 2 meter plus another 2 meter. So pi and pi are like terms. This is 16 pi, and 2 plus 2 is 4. So this is our answer here. So you then write 16 pi plus 4. The reason why we are not multiplying out the pi, because the question says give your answer as a simplified expression in terms of pi. So this is our answer. All right, then I look at question number 6, which would be the last question on this first segment. They tell us that a solid metal cuboid has volume that, okay, the base of the cuboid measures 10 centimeter by 12 centimeter. So if you know, if you've got if you want to make a diagram, we can make this as our cuboid, maybe in this case, okay. So that is our cuboid there. We draw the cuboid. So then you know that this base here, you are told that it's measures 10. So let's say this is our 12, this is our 10, and then we actually don't know the height, okay. So what we know is that to find the volume of a cuboid, it's L times B times height. In this case, we've been given what the volume is. So we know that the volume is 600 equals the length 12 times the breadth 10 times the height that we want to find. Now in this case, we are going to say 12 times 10 gives us 120 h equals to 600. We want to find the h, so we divide by 120, we divide by 120. So the height is simply the answer that we get when we do 600 divided by 120. If we do that, we would find that the height is actually 5 centimeters. So this is what they wanted to do, 5 centimeters. So that's the height. What was important was remembering the formula, but again, this is now being given in your exams as part of the formula sheet, so you just need to know how to use that. So now on this other second part, they say the same cuboid is melted and made into 1,120 spheres, each with radius 0.45 centimeters. So it's like we've got a sphere, so we're going to write a sphere, each with radius for 0.45. Okay, they say find the volume of metal not used in making these spheres. So what we need to know first is the formula for finding the volume of one sphere. So we know that volume of one sphere is 4/3 pi r cubed. Okay, so what we need to do now is to find the volume of one sphere, which is this one, then the answer multiplied by how many spheres we've made. So this is going to multiply 1120. So if we do that, 4/3 times pi times the radius, which is given as 0.45, but this is cubed, times 1120. So we can know the total volume that was made. This is going to give us, so if we use our calculator there, we have 4 times 0.45 times, so I'm just working out this, times pi, then so now since they want us to find what is left of that 600, we are now just going to do 600 minus 427.5. so if we do our math, you will then find that the answer is going to be what would be left is a 172.5 cubic centimeters of the 600. So the answer is 172.5 cubic centimeters. So thank you very much. We shall do a part 2 of this workpack and see how we can answer the other questions. So we've done the first 6 questions and they're actually nice. So thank you, and please look out for the next part.